Hi, Jesse.
Hi, Alan.
How are you doing?
Good. How about yourself?
I'm good. I'm fit. I'm well.
So, what's been happening at Neptune?
Well, last week I already announced that we have a recursive verifier, and that was a major milestone. But the thing with major milestones is that they induce a sequence of two emotions in rapid succession. First is pride, and second is frustration. Frustration, of course, because it's not good enough. Because we can tell that there's so much opportunity for making recursive verification faster, and that's what we've been deploying our collective attention towards the last week. And there are actually various angles that you can attack this problem from. So on the one hand, we're hand optimizing the assembler code for the verifier. On the other hand, we've identified um, runtime bottlenecks that were not on our radar beforehand for proving large programs, and we know that we can fix those runtime bottlenecks because they're coming about as a result of a suboptimal algorithm that was not on our radar as a potential bottleneck because
So how
but
are you benchmarking this? How do you know it's slow?
well, we have a profiler and we have a fine-grained insight into how much each method takes.
So what is slow? What was the output that made you think, oh, that's slow?
Uh, it was specifically the steps needed to compute polynomials that are necessary to prove the integrity of memory. And so it's arithmetic coming from a particular part of the proof system. And yeah, we had all parts flagged in our in what is it marked in our profiler, and then this one part seemed way out of balance relative to the rest, and so then you start
But
prodding and poking and
out of balance in terms of the amount of steps it wants to take, or in terms of just time?
time. And then you discover, oh, actually I'm using an n squared algorithm here for an n that I didn't realize was significant, whereas in fact we can use n log n everywhere. What is it? N log n squared everywhere. So
You
yeah,
might you
we're just
might
going
you
to
might want
update that.
to you might want to explain that convention.
Um, yeah, so this has to do with how the performance of algorithms scales as a function of their input. And the S in Stark stands for scalable, which in the acronym Stark means that the prover has to run in at most n times logarithm of n to some power. Um, and yeah, that means it's if your input is twice as large, then you run the prover for almost twice the time, twice and a tiny bit extra that is basically negligible in the grand scheme of things. Um, but we were using an n squared algorithm somewhere, uh, and where n, concretely speaking, is not the size of the program, it was in this case it was the number of addresses accessed. And so the reason why this wasn't on our radar is because we were not counting the number of addresses accessed. But when you have a milestone, you look at everything and you make sure that all the timing information balances out, and then there was this odd factor that seemed way out of proportion.
So is it fixed?
It's not fixed yet, but we know how to fix it, and it's 80% fixed.
Okay.
And so that's going to be another source of extra speed, and another source of extra speed. Well, another source of extra speed is coming from the reduced memory consumption. which has been one third of the optimization steps that we can do there has already been done. And so concretely, the memory cost is half the previous memory cost, and that means that that a smaller machine will do, or if you want to do it on the same machine that we were doing it on, then you don't need to use the SD drive as swap. So basically, one of the reasons why it was slow was because we needed more RAM than was physically available, and we were using the drive to simulate RAM. But now it all fits in RAM because of the reduced memory requirements.
Okay, cool. And I saw Torquil posted a blog post about the milestone.
Yeah, and it's also a very much what is it, current perspective, because he also articulates to some degree the two emotions, pride and frustration, and he also lists a bunch of knobs and levers that we can turn and pull to make it
So
faster.
how does this what do you call it? It's a recurrent prover
Recursive
or
prover.
recursive
Well,
prover.
recursive verification actually, but the point
Hmm.
is that the correct verification is the thing that's being proven.
And how does it compare to others out there? Like I think last time you remembered Starknet, they have one. How does it compare to like what's out there in the industry?
How does it compare in which metric?
You tell me. I guess we talked about speed just now. What other metrics would there be?
Security. I think most other recursive proof systems, they target a security level of 90 bits, if that. For Starknet, I don't think they would drop it quite that low. I don't know concretely what it is for other projects, but we're kind of making it difficult for ourselves because we are targeting 160 bits. And that means that our proofs are larger and take longer to verify and so on.
And so, what you're mentioning a security benchmark. So, can you explain that a little bit? What does that mean?
Well, it's the hope is that we can condense into one number the attack cost in order to subvert the crypto system. So if you want to produce a stark proof of a falsehood, how much work does it require? And we count the exponent of a count of
Oh wow!
steps. So yeah, 2 to the 160 is a very large number. And we calculated this because it doesn't seem feasible with all of the resources available in the solar system. And it makes
Okay.
sense because Neptune is the last planet in the solar system. And once you want to have blockchain money between different solar systems, the time delay is a bit of a
So,
problem. So,
so this reminds me of something we talked about on a previous episode where we talked about Neptune analogous to a car, and that Neptune, the idea being Neptune is a better car than say Bitcoin. It's like the Tesla versus the whatever other petroleum cars out there. And so, how have you and your team thought about sort of what happens to Bitcoin once you bring out that better car? Is there yeah? So any thoughts there?
we're certainly standing on the shoulders of Bitcoin, and so even if Bitcoin trades at a negligible price, it continues to exist in Neptune, um, because the ideas are the same. Um,
But
yeah,
is it like you've got the analog camera and the digital camera comes along, but then there's still people that like the analog camera, or is it more like you've got dial-up internet and then broadband comes along, and then at some point no one has dial-up anymore because it's worse. Sort of two extremes.
yeah. I think it'll be more like cameras. I think Bitcoin will have some diehard believers, and yeah, a lot of the things that we think of as improvements are not universally regarded as improvements, right? And there's an argument to be made in favor of traceability, because it makes it easier for banks to start adopting Bitcoin, because the regulator is not as opposed to a traceable coin as it is to a untraceable coin. And so right now, as it stands, banks are probably more likely to um, support receiving and holding Bitcoin than Monero or Neptune down the line.
Yeah, which makes sense. Okay, switching gears, no pun intended. I was wondering, with regards to mining, because I know that in the Bitcoin sphere, there's this concern about the block rewards for mining going down throughout, further along you get. And I was wondering, how have you guys thought about that? What's sort of the monetary policy for miners? Any thoughts on that?
We have thought about it, and I should also mention that whatever we've decided up until now is still not final, and we might revisit those decisions or some of those decisions. Um, One of the things that we seem to be dead set against is changing the supply limit. There will be 42 million tokens and not a single billionth of a token more. Period. And so, in order to achieve a hard supply limit, you need to you need to shrink your mining
But why
reward.
why
Go ahead.
why are you so dead set on that?
We think it was a big factor, convincing people that Bitcoin can is capable of storing wealth, because you're guaranteed by the laws of computers that your share of the pie is not going to shrink. And this is a completely, before Bitcoin, this thing didn't exist. Not even gold had that. Not even diamonds have that, because you can create gold in a lab. You can create a spaceship and sail to the nearest supernova and farm gold as it's being made while the universe is doing its thing. Um, Diamonds don't have that either, right? You can produce diamonds in the lab, and currently they are small, but what's to say that in future labs those diamonds will still be small? Um, but with Bitcoin, you know with much greater certainty that your share of the pie is not going to shrink. And that's one of the most awe-inspiring things in my eyes, that we wanted to adopt for Neptune also.
But awe-inspiring. I mean, I get that it's some it's a type of limit that doesn't exist in nature,
Correct.
which is pretty cool. But that doesn't make it useful.
Doesn't it?
No.
Bitcoin is useful because you can trade it, and as long as there is a non-zero value, or rather, as long as it trades at a non-zero exchange rate, it's useful because you can use it to affect trades.
No, but I'm talking about the usefulness of capping the amount of coins?
Well, it's how people assign this first non-zero exchange rate.
You think it would not have caught on if it went on
Bingo.
indefinitely?
Even though if it had gone on indefinitely, you could still compute a net present value. And the net present value is finite. But you cannot compute the size of your slice of the pie.
That's interesting. Okay, so you're all sort of unified on that belief that that's an important part of the puzzle.
Yes, but uh, we're also concerned about the ecosystem, in particular in regards to mining down the line when the mining reward has disappeared or is negligible. Um, and so our position is, if it turns out that you need mining rewards, then the community should hard fork Neptune, and may the best fork win. What we are building has a 42 million absolute limit, but we're not going to be around forever. These decisions will probably be made after our lifetimes, and so if a hard fork is necessary, let people will hard fork it for smaller reasons. Let them hard fork it for this reason too, and let's figure out if it really is necessary.
And I know that in the case of Bitcoin, I think 2140 is mentioned as the year where there will be no more block rewards. I'm not sure how they arrive at that number, but is there a similar number that you can mention for Neptune, or how does that
There is
work?
a similar number. For us, it's 386, 384 maybe years after launch, when the last atomic unit of Neptune will have been mined. And the reason why there is this final limit is because both Neptune and Bitcoin use a finite a set of bits to represent amounts. And so if you keep having an amount, at some point you're going to run into rounding errors. And at some point, I mean, every time you have the amount, you just shift your bits to the right, and whatever the rightmost bit was gets erased. And so there's only a fixed number of shifts to the right that you can do before you arrive at zero. And if you count how many halvings that corresponds to, and what year we will be in when we reach that point for Bitcoin versus Neptune, that's how we get to this 130 versus 380 uh, no, years.
Interesting.
We did
So
consider on this topic, if I may digress a little, we did consider supporting arbitrary precision amounts, um, so that you could have indefinitely, or basically indefinitely, right? Because the way we had thought of doing this was using dyadic rationals, where you store the binary string, what is it, the binary expansion, but also the exponent that's by how much you shift that binary expansion.
so you would get around the problem with the bits by using a different data structure.
Exactly.
That's something you considered.
And we came to the conclusion that supporting this data structure in assembler for Triton Virtual Machine is, it's possible, but it's
So
it's just so complex, and it doesn't seem worthwhile.
So assembler is one of the lowest level computer languages. So it's the closest to the hardware. So why are you using assembler in this case?
Not because it's close to the hardware, but because it's close to the virtual machine. Triton. So this is Triton assembler, and you can think of it as the language that the Triton virtual machine natively understands.
And why do you need a virtual machine again?
Because we want nodes in the network to agree on state updates. And those state updates are brought about by transactions and blocks, and they need to agree on which transactions are valid and which blocks are valid. And so they need to run the same computation everywhere. And if you
Right, so it's a machine for computing
and
the state.
and if you try to do that without a virtual machine, then you're going to run into the problem that every physical machine is different. And so maybe all the Intel computers agree, but between Intel and AMD they disagree, or some weird shit like that. Newer generations
So, so,
disagree.
so you've got this mechanism that every node runs that has an internal logic, and that logic is used to keep track of the state that comes in and sort of to build that up. And now you were talking about that language is Triton
Correct.
assembler.
Well, that logic has to be described in Triton assembler. Yes.
Okay. Okay, cool. Anything else noteworthy that happened last
Not that I
week?
can think of. Yeah, in the legal landscape, the judge in the Copa case issued a freezing of Craig Wright's accounts internationally. Um, I thought that was uh, surprising. I did not expect the judge to come out so hard on the side of deciding that.
So this is the Satoshi
Yes,
imitator,
and
right?
who's basically now
But,
being ruled to be fraud. Um,
but isn't his claim that he's locked out of his Bitcoin addresses already?
that is his claim. Yes, I'm not sure I understand the already part.
Well, because the judge ordered that he should be locked out of all his
I
accounts or
think
bank accounts or what.
the order that dropped last week was about his bank accounts.
Okay.
So yeah, it looks like his legal play is coming to an end.
And so from a cryptographer's perspective, why is it
He
obvious to
doesn't
you
know
he's a
what
fraud?
unsigned integers are.
Okay. And he mentioned that in an interview or what?
He was quizzed on that point and plenty of other points in the course of the trial. And so the plaintiff lawyer asked him to describe what does an unsigned integer do, or something to that effect, and his answer didn't make any sense.
Wow. Okay. Cool. Well, I think we can wrap up
Sounds
for
good.
the week.
Looking forward to next week's conversation.
Thanks, Alan.
Take care.
Yeah. Good luck next
Bye bye.
week and take care.